Crystal field energy of octahedral complexes, explained by myself, Dr. S. Jinilmo. Introducing the crystal field theory, it's the most important widely accepted theory in metal ligand bonding of complexes. The central metal ion and the ligands are bonding is purely electrostatic. The ligands may be negative, neutral, or in rare cases positive. The electrons of the central metal ions are under repulsive forces from those on the ligands. The electrons occupy the d orbitals furthest away from the direction of approach of the ligands. This is the representation of an octahedral complex. We have 2 axial and 4 equatorial bonds or groups. The Eg orbitals are shaded and the T2G orbitals are unshaded. The splitting of the d orbitals in an octahedral field, you could see that the 3 T2G orbitals are the lower energy and the 2 Eg orbitals are the higher energy. T2G in the sense dx xy, dy z and dzx. Eg orbitals are dx square minus y square and dz square. Based on this, the crystal field splitting energy of an octahedral complex is minus 0.4 into n of T2G plus 0.6 into n of Eg. This term n of T2G is the number of T2G orbital electrons and the n of Eg is the number of Eg electrons. The CFSE value is 0 for D0 and D10 configurations and also for the D5 in a weak field state. Giving minus 0.4 for the T2G orbitals and plus 0.6 for Eg. These are the values. The values are listed below for all the systems in an octahedral complex D1 to D10. This is for weak ligands and this is for strong ligands. The size of the energy gap between delta octahedral, that is the energy gap or the crystal field splitting energy, can be measured using UV visible spectrum of the complex. This complex considered here is titanium aqua complex. The system is D1 system. This is the ground state and this one is the excited state. The electronic spectrum shows a single broad peak at 2030, which is the DD transition, and this is the steep part of the curve due to charge transfer. And applying the formula, we have 1 kilojoule per mole is equal to 1 kilojoule per mole is equal to 83.7. Applying that here, delta octahedral is equal to 20300 by 83.7. 20300 is taken from this peak and 83.7 is 1 kilojoule per mole. Thereby the value is 2243 kilojoule per mole. Because of the crystal field splitting of d orbitals, the single d electron occupies an energy level 2 by 5th of the delta octahedral. The value is minus 0.4 delta octahedral. That is calculated from the CFSE formula. Now substituting the value of delta octahedral here, crystal field splitting energy is equal to 0.4 into 243. That is 97 kilojoules per mole. Thank you for your kind attention.